Welcome to HelpYourMath.com. In today's video we're going to cover the negative exponent. Now before we begin dealing with the algebra, I want to talk about some of the arithmetic properties of negative exponents and how to handle them. This way when we transition into the exponents of variables we can see that there's a big relationship between the two and the ideas are not so different. Alright, so when we're dealing with negative exponents, the idea is that the negative term reciprocates the number and the value. And when we reciprocate this, what happens is the exponent changes from negative to positive. And so when we have 3 to the power of negative 3, we get this reciprocated. So the reciprocal of 3 is 1 over 3. And then we apply the exponent to the denominator of this, right? So it goes from negative 3 to positive 3 when it shifts to the denominator. So technically we just put the 3 to the negative 3 over 1 and we reciprocate it by moving it to the denominator. And then we just expand the exponent. So 1 over 3 to the power of 3 becomes 1 over 27. And the same way we reciprocate a numerator to a denominator, when we have a denominator with a negative exponent, we reciprocate it and move it to the numerator. And so this becomes 5 to the second power. It changes from negative to positive when it goes up, and we replace the denominator with a 1. And then here what we get is we get 25 over 1, which is just 25 when we divide it by 1. And so some of these properties will become very familiar when you're working with these. As we see, when we have a negative exponent with a whole number, it becomes a fraction. And when we have a fraction with a denominator with a negative exponent over 1, it becomes a whole number. And so now let's begin running through the 9 problems, in which we have 2 special problems at the end which are dealing with power rules, which are in a later video. But I'm going to introduce them now because the power rule outside has negative exponents as well. So let's begin with this video set of 9 problems. Our first problem here is just x to the negative 4th power. And when we have a negative exponent, again, we want to reciprocate the term. So our first step is to put this over 1. Since every number is a fraction, in this case, we'll make this number a fraction, right? This variable. And what we're going to do is we're going to reciprocate this then. So the x to the negative 4th goes to the denominator and becomes a positive exponent in the denominator. And that's our final answer, just 1 over x to the 4th, in which this step is not necessary. This is just showing you the change of the exponent from negative to positive when it transitions and transposes down. Let's deal with the second case now, where we have a fraction with the denominator exponent is a negative, where we have 1 over x to the negative 4th now. And so in this case, when we reciprocate, this is going up to the top and it becomes x to the positive 4th up here over 1. And when we divide this, we just get x to the 4th. So basically what's happening is when we have a negative exponent, we have to move it, shift it from either the numerator to the denominator or from the denominator to the numerator. And if we don't see the fraction, we make the fraction by putting the term over 1. Alright? If it's already in a fraction, it's just shifting to the top of the fraction. So now let's deal with cases that have constants in front of them. We have 3x to the negative 2nd power. Again, we just want to put this term over a 1 and then shift the negative exponent down. We get 3 over x to the 2nd power. Now remember, when we have a negative exponent, very much like the 0 exponent, the exponent is only affecting what it's next to. So in this case, we see that this is 3 times x to the negative 2nd. And when we're transitioning the negative exponent, it's only affecting what it's directly on. Not the pair, because it would need to be in parentheses to do that. Alright? So let's move on to number 4 now. And in number 4 we see we have the same case, only this time 3x to the negative 2nd exponent is in the denominator, where these are multiplying. And so the negative exponent is only affecting the x. And so only the x moves up and changes sign from negative to positive, while the 3 remains in the denominator. Now, you may get these separate, right? Where one term has a negative exponent while the other one doesn't. So in this case, I'm actually going to show you guys when the numbers are separate in fractions. So here we have a positive 5 up top, and we have an x to the negative 2nd on the bottom. And in this case, the negative exponent is going to leave the denominator and go to the numerator. So we have 5x to the 2nd over 1, which anything divided by 1 is just what it is. So we have 5x to the 2nd here as a result. And so this becomes a whole number term, right? Well, just a number that's not a fraction anymore. in the case our exponent is negative in the numerator and we have a denominator that's a constant, we have to move this and shift it down to the denominator, which we replace the numerator with just a 1. And we have here 8x to the power 6 as our denominator. And that would be the entire translation of that part. Let's move on to number 7 here. And in number 7, what we're doing is we have 3x to the negative second power and y to the third power. This one's a little bit different because we have one term with a negative exponent, while the other terms are just fine. So what we're going to do here is the same as what we did with the first, the third. We're going to just move the negative exponent, all right? And so this is all in a fraction. We can consider this to be over 1, and only the negative term with the negative exponent term will be moving down to the denominator. And there we've simplified this problem. Most of your solutions when you're dealing with algebra problems are going to need positive exponents only. So these are usually some of the last steps we take after using the addition rule or the subtraction rule of multiplication and division with variables. So this is very important information when you're dealing with solving your problems. Now let's move on to a little bit of an advanced technique when dealing with power rules. And this is for problem number 8. And here we have 5x to the second power inside parentheses, while outside the parentheses we have a power of negative 1. And very much like the first problem, since this is in parentheses, we're going to transpose everything from a numerator, like we did here, to a denominator, and change the sign of the exponent to a positive term. And so in this case we have 5x to the second raised to the negative 1 over 1, and everything is going to go to the denominator, and it's all going to be raised to the first power, which anything to the first power is exactly what it is. Alright, so it stays 1 over 5x to the second. Now if the exponent had been a different power, we would expand it just like I showed you guys with the regular arithmetic properties, right? So if this were to the power of 2 outside, this becomes 25x to the fourth power. You can learn more about those rules when you're going to the power video set for exponents. So let's move on to number 9 here, which has one of the situations where we have a number outside the exponent here. It's not just going to be a 1. So we have 1 over 7x's raised to the power of negative 2. And so again, just like this problem, we have the fraction already, and we're going to transpose the term to change the power of the sign of the exponent outside the parentheses, and we're going to get 7x's raised to the second power over 1. And now we can evaluate this. And so this becomes 7x times 7x, because that's what we have when we have a second power of an exponent. And here this just becomes 49x squared over 1. And anything divided by 1 is exactly what we have, which in this case is just 49x squared. Thank you.